Magnets attract certain metals as well as each other. That's useful for more than just sticking stuff to the fridge. They aid in the operation of motors and generators, among other things. Magnets are found in nature. However, people discovered how to make them using electricity 2 centuries ago. It could be you can't see or feel the force that is lifting this globe. However, it is not magic. It attracts people. They must first make a sand mold of the magnet shapes in order to make magnets. This pattern of 4 magnet shapes is loaded into a machine, which fills it with sand. They scrape away the pattern and smooth the dimpled surface caused by the machine's lid. Then it's inside again. This time, however, the machine injects gases into the sand to chemically harden it. It only takes a few seconds to solidify. They remove the sand slab, revealing the magnet pattern impression. It has now become a mold. Magnets, like their molds, come in a variety of shapes and sizes. They are now ready to form the magnet shapes. Copper, cobalt, sulfur, nickel, pure iron, aluminium, and titanium are all used. All of these metals are loaded into an electric induction furnace. It creates a pulsing electromagnetic field that heats everything to over 1600 degrees Celsius, melting everything into a molten soup. They pour this into the sand molds. Because the gases that harden the sand are highly flammable, the molds burst into flames. They move the blazing molds to another section of the foundry and knock them to the ground. Then they sledgehammer them open to get air inside. As a result, they cool and the gases burn off. They shovel everything into a bin and use wood else to separate the metal shapes from the sand chunks. A magnetic field. The molded pieces behave like regular metal. They don't have magnetic power yet. Some are in the shape of rings threaded onto a copper pipe. They'll go into electric motors. A ring-covered pipe is placed in a much larger tube. Then they center it by tightly packing silica sand around it. The rings will be held in place by the sand. In the following step, they use concrete to seal both ends, allowing the inner copper tube to protrude slightly. Then it goes into another electrical furnace. It heats the magnet-shaped tube until it is red hot. This prepares them to accept the electromagnetic field delivered by this metal rod. They slide it down the copper pipe's center and clamp it in place. Water keeps the pipe from melting while it delivers a low-voltage, high-current charge in a cylindrical configuration, which is important for motor magnets. They pierce the seal. The process has mildly magnetized the ring shapes. Most importantly, it has correctly oriented the magnetic field. They smooth out any rough edges. These magnets are essentially useless at this point. But this machine will give them more power. It charges the metal with an electromagnetic charge, which magnetizes it. The earlier establishment of a weak magnetic field laid the groundwork for this moment, ensuring that the magnetization is properly oriented. That's some serious magnetic muscle in all of its forms. Magnets continue to have a strong pull in our society because their unseen power keeps so many things running.